Hi everyone, this is your lecture video for section 1.5, Complex Rational Expressions. A complex rational function is a function where the numerator and or the denominator is a sum or difference of fractions. So take a look at this example here, this one that I'm pointing at right now. This is a complex rational function. The numerator involves a sum of fractions. The denominator involves a difference of fractions. In this section, you are going to be simplifying complex rational expressions. There are two ways to do this. The first method is to deal with the addition and subtraction of the numerator and denominator separately until you have exactly one fraction on the numerator and or one fraction on the denominator. After this step, you will divide the top fraction by the bottom fraction and simplify. Remember how to divide fractions. If you have something divided by a fraction, you will take the reciprocal of the rightmost fraction and multiply it by the leftmost one, or in this case, the top. So here in this example, you have 1 over x plus 2 divided by 1 minus 2 over x squared. And remember from the last section, in order to add or subtract rational expressions, you need to have the same denominator. So I find the LCD for the numerator, LCD for the denominator, write everything on the top in terms of the same denominator, and do the same thing for the bottom, as I did here in this step. From here, what do? The numerator, we will add those two fractions, so you end up with 2x plus 1 over x. The denominator, we will subtract those two fractions, so you have x squared minus 2 over x squared. Now, take a look at this guy right here. What you have right here, this is, give me a moment here. Oh my goodness, there we go. What you have right here on this step that I'm pointing at is one fraction divided by another. What do? We will take the reciprocal of this bottommost fraction We will take the reciprocal of the bottommost fraction and multiply it by the top. Multiplying those two fractions, what happens here? This x here is going to cancel out with one of these on the top. So you're left with x times 2x plus 1 over x squared minus 2. There are some of you that will not like this method for some of these problems. What's the other method? Let's take a look at this problem again, but with the second method. The second method requires you to find the LCD of all of the fractions present. That means to find the LCD of all of the fractions on the top and the bottom, all of them. And then what? You're going to multiply the entire complex rational expression by a hella fancy one of this form. The LCD over 1 divided by the LCD over 1. Remember that when you multiply fractions, you multiply straight across, cross-cancel where you can, right? Taking a look at the second problem, the same problem, using the second method. The first thing that we do is we find the LCD of all the fractions present. So looking at this problem, the fractions on the top are 1 over x, 2 over 1. On the bottom, you have 1 over 1, and you also have 2 over x squared. The LCD of all four of those fractions will be x squared. You're going to multiply this entire guy right here, multiply this entire thing by x squared over 1 divided by x squared over 1. You saw what I did here? I need to use the distributive property in order to continue with this problem. So what do I want you to do? Draw the damn parentheses so that you remember to distribute. So when you distribute that LCD, what happens? After you distribute, you're going to end up getting rid of all of the fractions that are present on the top of this complex rational expression and all of the fractions that were on the bottom. You'll notice here that if I factor out an x, you can see that this is in fact equivalent to the answer that you get when you use the first method. It is up to you to decide on which method you want to use for simplifying complex rational expressions. You should get comfortable with both methods. Why? So in that first method, it does require you to divide into or divide by a fraction, right? In calculus, you're going to see lots of ratios in this format, a over b divided by something, right? How do you deal with this thing? I'm going to write a 1 here. So you have a fraction divided by a fraction. What do? You take the reciprocal of the bottommost fraction and you multiply it by the top. You should get comfortable with both methods. Let's take a look at some problems. You are asked to simplify each complex rational expression with a method of your choice. I'm going to do this first problem with method 1. I'm going to do the second problem with method 2. So for this problem, you have 3 plus 12 over y divided by 1 minus 16 over y squared. So I'm going to rewrite everything so that I have fractions here. Look at the numerator. The LCD of the numerator is just y. So I need to take that first one and multiply by y over y on that first fraction. If I look at the denominator has an LCD of y squared. Remember, I am using the first method to simplify this complex rational expression. So I have 3y, let's see here, 3y plus 12 over y divided by y minus 16 divided by y squared. Now, if I look at that rightmost expression that I have there, I have one fraction divided by another fraction. What do? We will take the reciprocal of the bottommost fraction and multiply it by the top fraction. Okay, so I have a mistake here. Let me fix this. The LCD of the bottom fractions was y squared. So I needed to multiply this by y squared here, which means I have a y squared here. Sorry about that. All right, now let's simplify, right? So we can cross cancel. This y gets rid of one of these. So you have 3y plus 12 over y squared minus 16. You need to simplify as much as possible. You can factor out a 3 from the numerator. The denominator there factors into a difference of squares. From here, these y plus 4s will cancel. Our answer is 3 divided by y minus 4. So that's tackling this problem with the first method. Next example. This thing looks awful. My numerator is a difference of two fractions. My denominator is just one fraction. I'm going to tackle this problem with method 2. What is the LCD of all of these fractions present? LCD of x plus 1, x minus 1, and x squared minus 1. What's the LCD here? The LCD, because x squared minus 1 is x plus 1 times x minus 1, right? It's a difference of squares. The LCD will be x plus 1 times x minus 1. X plus 1 times x minus 1. This is the LCD of all of the fractions, not just the top or the bottom. It's all of the fractions that are present. So top and bottom, right? Okay, so what do? We're going to take this guy here. Sorry about that. We're going to take that guy and multiply it by a hella fancy one in the form of the LCD over 1 divided by the LCD over 1. You see that denominator there? I don't like it being written as x squared minus 1. Let me go ahead and write that as x plus 1 times x minus 1. All right, now what do? We just need to distribute, right? So distributing that right across and simplifying our results, what do we have here? Remember that when you do this correctly, you should end up with no fractions on the top and no fractions on the bottom. Notice that for this denominator here, you have 5 over the LCD times the LCD. Well, what's going to happen? The x plus 1s will cancel, the x minus 1s will cancel, right? I'll still write it here just so you can see what that step looks like. So let's see the cancellation. Bam, 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 bam. So on the top, we have 3 times x minus 1 minus 3 times x plus 1. All of this is divided by 5. Using our distributive property, we have 3x minus 3 minus 3x minus 3 over 5. The x's will die here. We're left with negative 6 over 5. Alrighty, everyone, that's going to wrap up this lecture video, and I will see you tomorrow.